distance between particles kinetic status number 5 thermal expansion and number 6 compressibility. These are the basic properties of matter. As we already discussed, matter is made up of small particles called atoms, molecules, ions, radicals, protons, neutrons, electrons as subatomic particles. These particles are placed side by side or little apart from each other, means there is a space among them. In solid, this space is minimum. If I see particles are closer to each other, the intermolecular force of attraction will be more. As there is a formula, force of attraction between the particles of an atom is directly proportional to the product of their masses. M1 and M2 are the masses of two particles, and it is inversely proportional to the square of the distance between them. This may be little complicated for you, but it is simply understood that if the particles are further, means denominator factor of the fraction is more, the quantity of the fraction that decreases. So further the particles, smaller the force of attraction. Nearer the particles, stronger the force of attraction. In case of solid, particles are very closely packed. Particles are very closely packed, and that's why the intermolecular force of attraction is maximum. And that's why particles are in random motion. Kinetic status, what I told you here, particles are in random motion. Since there is a very strong intermolecular force of attraction, the particles cannot move from away of each other, and that's why they keep vibrating in their mean positions. They just keep vibrating in their mean position. They cannot move. There is no space for movement. The same thing when the kinetic status increases, kinetic status means motion increases, then the distance they keep vibrating and ultimately break the intermolecular force of attraction, moving little away of each other, and then the liquid state comes. Here the kinetic status is little more than that of the solid. In case of gas, the total bondage between the particles, total bondage is finished. Say, it is what you call molecules are free to move. Molecules move in random motion. Molecules do not have any restriction. Since medium particles are there, molecules are also made up of the matter is also made up of particles. They keep colliding with each other, and after colliding they don't maintain the direction, so they move in a zigzag irregular manner. So kinetic status actually is responsible for all these things. Molecules are closer to each other, that increases or decreases the force of attraction, and kinetic status means if you hit a matter, the molecules keep vibrating further and increases the kinetic status, and they move away of each other. So the thermal expansion, when you hit a matter, in case of solid the expansion is little, in case of liquid it is little more, and in case of gas it is maximum expandability. It can expand maximum to a maximum extent in case of gas. So these are the main features, properties of solids, liquids and gases. Solids maintain their fixed shape, fixed volume, they have got number of free surfaces, all depend on the same intermolecular force of attraction. Since molecules are closer to each other, intermolecular force of attraction is very strong, and they give a definite shape, definite volume. Yeah, free surfaces are not restricted for that. But in case of liquid, liquid has got only one free surface. If you see, this water has got free surface, only the upper one. This upper surface is free. If I remove this upper surface, if I just turn it over, upper surface if I remove from there, means if I bring it to the vertical, means vertically turning upside down, the water will slowly fall down. The reason is the upper side is not free one, it was restricted, it can only have one surface. But in case of gas, no free surface is there. As molecules are maximum movable, they keep going away of the container. So in a gas, there is no fixed shape, no fixed volume, no free surface there. Intermolecular force of attraction is almost negligible, 0. Intermolecular space is maximum. They are maximum expandable, compressible as well. As they are expandable, there are also maximum compressibilities they are seen in gases. Liquid practically not seen, but theoretically it may be possible. But in solid there is no compressibility at all. So we come to the chart again. That is, in case of solid, in case of liquids, in case of gases, these are the three characteristic sets. What you are going to do, you will be writing in a column to show these all properties. These all properties to be shown there to explain the solid, liquid and gases. Here is the solid, here is the liquid, here is the gas. Now we will be coming to the convertibility of these three states. Convertibility will be coming here is the convertibility of the states showing solid, liquids and gas. By boiling or vaporization, we can convert solids to liquid. In the same way, we want to come back to from liquids to solid, we have got solidification, or freezing. Liquid to gas or vapor. This is a different, same gaseous state but different existence. This is called boiling. Sorry, this is melting. There is boiling, vaporization. This is condensation. Or liquefaction. A vapor is condensed but a gas is liquefied. Actually, there is no process called cooling, which is withdrawal of of heat. Here also same thing, cooling. Here is heating. And there is a direct conversion, that is from solid to gas. This is called, back to solid. This is called sublimation. Actually, sublimation is both the way. Some books, some authors use the word deposition from gas to solid transformation. Sublimating substances, there are very few. 5 common substances what you normally use at home, you see at home, I use. They are camphor, naphthalene ball, that there is what you call ammonium chloride, iodine, and dry ice. Camphor, iodine, ammonium chloride, So we complete the class today. Here in this topic, we will continue in the next period. Thank you. भाई